Welcome to day 2 of unit 3. We'll have a little warm up for you to see if you can solve for x. Pause the video, work through these, see how you do. Unpause it, and we'll go through the solutions. So for this first piece, I know that I'm going to need a common denominator for the constant term. So I'm going to write 14 over 2 instead of 7. I'm going to subtract 14 over 2, or 14 halves from both sides, which gives me negative x is equal to negative 9 over 2, which means that positive x is going to equal a positive 9 over 2. For the second one, I would probably divide by 12 first, because then I don't have to multiply by 12. I'm kind of lazy like that. So 6 over 12 is 1/2. When I subtract 5 from both sides on this one, instead of minus 5 over here, I'm going to write that as minus 10 over 2. So I have a common denominator, and then I'm going to get negative 9 over 2. And now when I divide by negative 2 here, that's like multiplying by 1 over negative 2. We get x is equal to 9 over 4. Okay, so for both of these, I should be able to plug my answers in and see if my answers make sense. So 14 over 2, that's what we said 7 is, minus 9 over 2 is 5 over 2. If I do 9 over 4, if I plug that in, that becomes 9 over 2. 5 minus 9 over 2 is 1 over 2. And then 12 over 2, when I multiply, is 6, so we are good to go. For this section, we're going to be solving inequalities using inverse operations and graphing. It sounds intense. It's literally do the exact same things as we did when we were solving equations. So we are going to treat this thing like an equal sign. We're going to leave it exactly where it is. We're going to start by adding 2 to both sides to get to this. Now, from this step, this is the one real new piece of information. When I multiply both sides by a negative, or divide both sides by a negative, I'm going to switch the direction of this sign. So I have 20 is less than or equal to g. It seems like an odd thing to do, so I'm going to show you another way to do it if you don't want to multiply by the negatives. So if we get to negative 4 greater than or equal to g over negative 5, and I multiply both sides by a positive 5, it gives me negative 20 is greater than or equal to negative g. If I add g to both sides and add 20 to both sides, that gives me g is greater than or equal to 20. These two inequalities are equivalent. It's just a matter of which side does my variable end up on. So now to graph this, just like before, we need 3 numbers. I'm going to put a 20 in the middle because that's what I had right away. I need a number to the right and a number to the left. So I'll go 24 and 16 because I can. I have a closed circle at 20, and now I have to make sure I'm paying attention to which way the arrow goes. If g is greater than or equal to 20, or 20 is less than or equal to g, that means I have the numbers going to the right. For this second one, we just do our order of operations backwards again. So I have 2/3 x is less than 6. Multiply both sides by 3. Since it's a positive, the sign does not change. Divide both sides by 2. The sign does not change. I'm left with x is less than 9. So I'll put a 9. I'll put a 10 there. I'll put an 8 here. This is an open circle, and x is less than 9, so it'll be the numbers going to the left. If at any point you think I'm going too fast through these, go ahead and pause the video and rewind. It's a wonderful part about videos. So we're going to mix in a word problem quick. It says a city's record rainfall for the month of October is 16.8 inches. So far in October this year, 11.2 inches of rain have fallen. Find the average number of inches of rain that must fall each day in order to break the record. So find the average number of inches of rain. That means my variable, I'll use x because I'm super creative. This is the average number of inches of rain. That's the thing we're trying to find, so that is our variable. I have 14 days left to break the record, so I have to get the average number for 14 days. So I'm going to have 14 times x. I've already had 11.2 inches of rain, and I need to break the record, meaning I need to get more than the 16.8 inches that they've already had. If I'm trying to tie the record, it would be greater than or equal to if I said tie or break. If it just said tie, that's an equal part, but this says break, so we've got to get higher. Now that we've set up our equation, we subtract 11.2. Got 14x is greater than, that would be 5.6. Now I divide both sides by 14, and this is where having a calculator will come in handy. When I take 5.6 divided by 14, I get 0.4. So my answer is not x is greater than 0.4. Since this is a word problem, I need a sentence. So it says how much do we need on average to break the record? So the city needs to average more than or greater than 0.4. We're measuring in inches of rain each day to break the record. The hard part about these word problems is identifying your variable and making sure you get the correct inequality or equality symbol in place. So make sure you're reading very, very carefully. Now we'll have another word problem here where a dance group charges $15 for a membership. Members pay $8 to get into the monthly dances, but non-members pay $12. How many dances does Dave need to attend for the cost of membership to be less than paying as a non-member? So we have to have kind of two separate expressions, excuse me. So we have a member cost and a non-member. These are not my variables, but these are going to be my expressions. It's asking how many dances, so my variable, I'll use the variable d for dances, is the number of dances. Okay. For all of these, we are also finding a cost. So I'm going to say C is cost. So for a member, the cost is equal to $15 plus $8 for every dance. For a non-member, there's no $15, it's just $12 for every dance. This piece is not what we are solving for, but they are equal to two different things, which means I have 15 plus 8D is equal to 12D, because if I wanted those to be equal, but now I want the cost to be less than that of a non-paying member. So instead of equals, it should be less than. That's the only change from last chapter's word problem to this chapter. Is instead of equals, sometimes now we have an inequality symbol. So I'm going to subtract 8D from both sides, and when I do that, I'm going to be left with 15 is less than 4D. Divide both sides by 4. Now 15 divided by 4, you can leave as 15 divided by 4, or 3.75. So this says that D is greater than 3.75 dances. You can't really have a 0.75 dances, so Dave needs to attend at least 4 dances. Because you have to think of the context of the question. The context says we can't have a partial dance. You're going to the whole thing or you're not going at all. So that's why we had to round up. Okay, now for these, we're back to just solving and graphing. Divide both sides by 5 here. We've got x is greater than -4. I have a negative. I did not divide by a negative. Dividing by a negative is when you flip the signs. If you are dividing a negative, you do not have to change anything. So I'll put a -4 here. I'll throw it 0, and I'll make that a -8. Open circle at -4. X is greater. It goes to the right. For this next one, we multiply both sides by 4. We've got x is less than or equal to 48. So I'll put a 48. I'll throw a 50 and a 46. This is a closed circle, and it goes to the left. On this next one, we subtract 3 from both sides. When we do that, we are left with negative 2x less than 12. Divide both sides by negative 2. You got x is greater than negative 6 because we changed the sign. We divided both sides by a negative, so we have to flip the sign. So my number line would have a negative 6 here. I'll go negative 3, negative 9. Open circle, and this is going to the right. If you're unsure of this symbol, you can always plug in a number into this piece and into this piece and see if it works in both. So for an example, I would pick 0. If I plugged in 0, I'm going to get 3 is less than or equal to 15, which is true. If I plug in 0, I'm going to get 0 is greater than negative 6, which is also true. 0 would have been over here, so my arrow should go to the right. This next one, I cannot multiply by the negative 3 until I add that 7 to both sides. Now when I multiply both sides by the negative 3, I'm going to get x is less than negative 48. So I've got a 48, make it negative. On this side, it would have been the negative 46. This side would have been the negative 50. It's different than the one right above it because we are on the negative side. Got another open circle, and we are going smaller than negative 48, so that is going to go to the left. Now we've got a couple more intricate ones here. That's okay. I'm going to start by distributing. So my right side is going to change, but my left side is not. I just distribute. Now I make the decision, where do I want my x's to go? I like to keep my x's positive, so I'm going to subtract 2x from both sides. That gives me 5x plus 7 on the right. Then I'm going to subtract 7 from both sides to get here. And divide both sides by 5. That gives me 3/5 is greater than or equal to x. So I'll put 3/5 right there. I'll make that a 1. I'll make that a 1/5. Closed circle. And we are getting smaller. Numbers smaller than 3/5 for x. This next one over here, the left side still does not change. Make a better greater than symbol, but I need to distribute that negative. Now I'm going to add 2x to both sides, and if I want, I can subtract the 6 at the exact same time. That's going to give me x is greater than negative 10. So, negative 10. This would be a negative 8. This could be a negative 12. If we are greater, we have an open circle going to the right. Again, I'm going through these very quickly, but feel free to pause and rewind. Now these next two are going to go pretty quick. So if I distribute this, I'm going to get 2x minus 6 is less than 2x minus 6. If I subtract 2x from both sides, I get negative 6 is less than negative 6, which is not true. So I have no solution, just like we had no solution in last chapter. But I need us to graph this as well. So on the graph, you'll have a number line and then no solution. Write it again, so that I know that you know the graph matches what no solution means. For this one, when we distribute, 3x minus 12 is greater than or equal to 3x minus 12. If I subtract 3x from both sides, I get negative 12 is greater than or equal to negative 12. Because of the or equal to, this is true, so this is infinitely many solutions. So I need you to write that. We do have a graph for this one. I need 3 numbers. Literally pick any 3 numbers you want to. I'm going to go 1, 2, 3, and then I'm going to put a dot above one of them. And I'm going to have an arrow going in both directions because any number we plugged in for x would make this inequality true. For the next question, we have a soccer team trying to break the school record for goals scored in a season. Your team has already scored 88 goals this season. The record is 138. With 10 games remaining, how many goals on average does your team need to score to break the record? So I'm going to say G is the number of goals. I know that we've already scored 88 goals, and we are going to score a certain number of goals but we have 10 games remaining, so that average number of goals is going to be 10. So I should have thrown the word average in front here. I apologize if the hallway is a little loud right now. Hopefully it doesn't show up too much on the video. I want to break the record of 138 goals, so I need to score more than 138. So this is my inequality. Subtract 88 from both sides. I've got 10G is greater than 50. Divide both sides by 10. That gives me G is greater than 5. So on average, the team needs to score more than 5 goals per game. To break the record. Word problems always end in a sentence. All right, so that was inequality, solving inequalities. We threw some word problems in there to mix it up a little bit. Here's a spot for you to write what we talked about and any questions you may have. Hope everybody has a great day.